Hello, ladies and gentlemen. In this video, and you might immediately be drawn to the 1, and you might say to yourself, well, I thought we were done with constructible numbers. We're not quite. I know it was a little while ago, but I'm going to bring them back because in this video I want to pull together a lot of the things that we've seen so far. So I was thinking about my construction of the regular pentagon and the regular 17gon, and we use sort of, given points A and B, and then we use that to construct a circle, and inside that we construct the pentagon. And the AB length is not sort of the side length like it was in the square video or the hexagon video. So what I wanted to do is show you how to create a regular polygon with a given side length. And I'm going to construct that side length from my 1. So it's going to be a constructible polygon with a constructible number for its side length. And I've chosen, I'm not going to do anything particularly crazy, but I've chosen 2 plus root 3 as my constructible number. So we're going to start with just the unit length, and we're going to get this whole thing. And I haven't said what polygon we're going to do. We are going to do a 30-sided polygon. Okay, so this will bring in the construction of sort of the 15gon from the 3 and 5 gons. And it'll also bring in the how do I construct a 2 n-gon from an n-gon. But first things first, I'm going to get our side length going. So we need 3 in order to make square root 3. There we go. And so now we've got 3 there, but we've got our 1 sort of embedded in there. What do we need to get square root 3? Well, we need 1 followed by 3. So each of these circles here has radius equal to our 1. So here we go. So now we have 1, and then we'll follow it by length 3, and they're on the same line. This is going to be the diameter of a circle that we're going to use to construct our root 3. Now I know the center of the circle was also one of the points that I just hid because this has a diameter of 4, so the 2 position was our midpoint. But I'm just going to construct it in general. It happened to work out that I wanted to do root 3, and so it just happens to be nice. But we're going to show that it doesn't have to be. So here we go. We find the midpoint wherever it is, but it was already a point that we had. No worries. So I'm going to connect it up, and there we have the circle that we're going to use to get root 3. Okay, so what do we need to do? Well, we need to get a line perpendicular to the end point of the 1 closest to the center of our circle. Not hard. Just pick another point, say the diameter. Now we'll get intersection point there. I should note that once again, this center is being quite nice. We would be constructing this circle, but it happens to be one we already have, so we don't need it. So we have this perpendicular line here. And now the length from our blue dot up is root 3. So we want root 3 plus 2. So let's put root 3 down here on the line. Get rid of this circle. Get rid of a lot of this. So now we've got 1 plus root 3. We need 2 plus root 3. Oops, wrong way. We got 1 plus root 3, we just need to add on another 1. So we go from this side, and now we have our total length. So if I may be so bold, this purple length here is the 2 plus root 3 that we're going to use. Okay? So, I'm going to keep this length around, but I need a length to start my construction. And we're going to make a 30gon by making a 15gon first, and then doubling the number of points. How do we make a 15-gon? Well, you might remember from the video that we make an equilateral triangle. And we also make a regular pentagon. Okay. And we make them both inside the same circle. Now we're not this AB here is not going to end up being the. We first need a 15-gon, then we'll scale it to the right size. Okay, so we're just using the length because I don't want to create an arbitrary length like that. Okay. So what else do we need? We need a vertical line. So now this top point here that I've just created, it's going to be the top of my 15-gon. I'm going to have that be the common point. So we're first going to construct the equilateral triangle. Okay. How do we construct the equilateral triangle? Well, we get ourselves these points over here, and then now with the top point we get an equilateral triangle. So I'll make it orange. Orange equilateral triangle. Okay, now we need the regular pentagon. And so what do we do there? So the regular pentagon, we're going to get the midpoint of this segment over here. Okay, connect that up to the top, and then we need to bisect this. So we're going to do a little bit of cleanup. So we want to bisect this. So we'll get another point and then perpendicularly bisect this point with the center. Make sure that that is attached there. Now get our straight edge out. There we go. And wherever that hits, that's the point we want. So now we can get rid of all this clutter. There we go. Isn't that looking good? Now we need perpendicular line through this. And this gives us our points on the not equilateral triangle, regular pentagon. Okay, so now if we want to, we can just show, yep, we got ourselves the pentagon. We don't need the full pentagon, however. Okay, we need to create a 15-gon. And if you saw in my 15-gon video, the distance between these 2 points here covers the distance between not 2 consecutive points on the 15-gon, but 2 that have only 1 point in between. So this represents sort of 2 edges of the 15-gon. We can take this around the circle, all the way around the circle. So get rid of some of these extra points here that we just don't need right now. And with these two, we're just going to go around the circle. Fill the whole thing in and get ourselves a 15-gon inscribed in this particular circle. Now that won't be the 15-gon that we will use at the end. In fact, no, we're going for a 30-gon, right? So we'll then take that 15-gon and extend it to a 30-gon, but that won't be the one that we use in the end, because that'll still be inscribed in this circle, and we want to use the side length we constructed oh so long ago. So we go around this circle, we'll have to have 15. You'll notice we still have that intersection point. Everything worked out fine. There's our midpoint between the two that we started with. Yeah, okay, that went second there I thought it misclicked. So almost done, almost around the circle. Got to make sure this point here didn't have anything going through it. Alright, and now we're back to a point that we've already got. So it's nice, it's full, it's complete. So we'll clear up all this extra work. In fact, I probably could have gotten rid of those green lines a little earlier. So this will get us the 15 gone, but we don't want the 15 gone. We want the 30 gone. So what do we need to do? Well, we need to zoom in a little bit. This 30 gone, I've been saying in the past, I don't want to do more than a 17 gone, and the reason is this sort of looks like these are evenly spaced. If I were to draw the 15 gone, it'd be very hard to tell that we actually do have a 15 gone and not a circle. And the 30 gone's going to look even worse, but I'm going to do it just to show you that we can do it. So we need to connect these up to one another, because we need, now we need adjacent ones. And I realize now I probably could have just drawn a little bit more of the pentagon and saved myself a lot of work, because I would have had these circles instead of the other circles that I had. No big deal though. So we need points out here. I'd add the points inside, but they're all going to run through the center anyway, so it isn't particularly required. We actually only need, I believe, half of these. Now when I connect them up, oh no, I do need the other ones. Because I need intersection points with these lines and these circles. Okay. And I think these are the last two. And there we go. That kind of looks really psychedelic. If you move back and get kind of close, it looks like you're sort of in a tunnel. Anyway, let's clean up a little bit of this. We don't need these purple circles anymore. We do still need the points that were on the 15 gone, because they're going to be on the 30 gone as well. Oop. Okay, and now we've got points that are evenly spaced in between them. Here, evenly spaced. Everyone that is not running through one gets a point. Anything that's not running through something that was already on the 15 gone. So now they're evenly spaced, and we can get rid of Just a whole bunch of stuff. Still not that constructed length. Okay. So here's the 30gon. And we actually just realized I made myself do more work because we really only need 3 of these because what we need is just the angle, and then we'll reproduce the angle. But I mean, there's your construction of how to do a 30gon if you ever needed it. All right, so we don't need most of these points. We only need 3 of them that are adjacent to produce the angle that we want. So these 3 up here will do. Let's connect them by a line segment, a forced green line segment. But you can see it's barely noticeable how the difference between this and the circle. All right, so what we need to do now is take our length that we want and reproduce it up here. Okay. So parallelograms to the rescue. Where do I want this length? I want to produce it that way. Okay. So, well, parallelograms, we've done several of these before. Okay, down there. Just readjust ever so slightly. Yep. These bigger circles, so now I'm going to have to zoom out again. There we go. And we get a perpendicular line through there. Intersection point here. Other side of the chord. One parallel line down. Okay, we need another parallel line. A line parallel to the one containing 1. So let's clean up a little bit. Alright, and we'll get big circle here. Okay. So intersection point there, and the remainder of the chord. So this gets us the remaining parallel line that we desire. Alright, let's get rid of many of these circles. In fact, this circle doesn't need to be around anymore. Okay, so where's our parallelogram? He ends right here. So now from this middle point here to this brand new point is a duplication of our length, 2 plus root 3. Okay, so we now take him, we want to put him on the same lines. We'll clean up a little bit so you can see what's going on here. So now we've got these lines will give us the angles we want. Put him here. Put him here. Now we've got the same angle, but because we use the center as a radius, and we know the radius is going to be the duplicated angle, suddenly, there we go. Okay. Oh, actually, I only just noticed that because we used this length to also construct our circle, we're passing through this point here, and we could have saved ourselves a whole lot of trouble just using this center point and this radius here. So this isn't the first time during this that I've done extra work. I shouldn't have made all those 30 points, but there we go. We've got the angle that we need. So now it's not these old points, well, one of them, the middle one we need, but these 3 points lie on the circumcircle, and they are equally spaced apart to make a 30gon. So now we don't need our original length at all. So hopefully I've convinced you guys that that is indeed 2 plus root 3. So now we just need to get a circle for these guys. So as usual, the perpendicular bisectors come to the rescue. And look how far out we have to find this intersection point. But now at long last we have the circumcircle for the big 30gon that we want. I suppose I could have kept one of those circles. Alright. So now circles all the way around, and this is just a little tedious work. But we're going to get it done, and then we're going to bask in the glory of our 30gon that has been constructed to a length that we want. So I'm going both ways so that at the end these circles will meet up and we can say, aha, we really do have a regular 30gon. Because we already know we're going to get the length we want. Is this a diameter here? Not quite, but down here would be, and that means that we've done some good work there. So we'll zoom out. We need a little bit more space. Not much to talk about when you're just creating circles. But we are almost there, and then we'll connect up all these dots and have a 30gon of side length 2 plus root 3. And of course you could use any... Oh, look, they came together at the same point in the middle. You could use any constructible side length you want. This is just an illustration of various techniques that we've used. So now, get rid of all the circles. And this center point, we don't need him. They are not wanting to disappear. There we go. I do have to select them all. I wish I could just box it all, but I'd get the points and I'd turn them invisible as well. So there we go. What color should we make? Well, we hardly ever make it blue, because I usually reserve blue for... What's this extra point doing here? I usually reserve blue for the starting one or for my points, but I think it's such a nice achievement. Let's make it blue. And there it is. So as I'm fond of saying, I think low resolution viewers might not be able to see, but this really is straight lines, and it is a 30gon, and however I vary my 1, this gets bigger with side lengths in the ratio to this little 1, this unit length here. Side lengths are 2 plus root 3 times as long. So I think that's pretty cool. I think that's using a bunch of the techniques. We made a 2gon from an n-gon. We made a 15gon after making regular pentagon and regular equilateral triangle. We used some parallel lines to translate things. Some of the techniques we learned for constructibility, constructible numbers. So I just think that's nifty, and I think that's a great way to sort of end this series. You can just I'll mess around with some of the lines here. I feel like I'm just gonna screw with this for a bit, but oops. Nah, I think the closing shot should probably... I was gonna start putting patterns in here, but I think the closing shot should probably be a glorious blue regular 30gon. So hopefully you guys have enjoyed this. This sort of lessons on straight edge and compass. And you know, if somebody in the comments comes up with a good one, maybe I'll add one to this series. But I think I've done everything I really like and want to do with straight edge and compass. GeoGebra, free from what I remember. Fantastic environment. We didn't even use most of the tools. We just used straight edge and compass here. And I think for the conic we used this point. But it's a very robust program. I don't use it nearly enough to know everything you can do with it, but there's some cool stuff you can do with it. And so, yeah. Hopefully you guys liked it. If you liked the series, let me know, because I can try and make some more fun little sort of math and teaching sort of topics. But it's almost been a little bit of a course. Almost. It's certainly long enough. But if you like that sort of stuff, let me know, and maybe I'll make some more in the future. Okay. So that's it for me. Have yourselves a wonderful day, and keep finding time to do some math.